Today's video is going to talk about CNI integration. And the question I get a lot is what Kubernetes CNI or what CNI to use with F5 Big IP? And that's a really good question. And so what I want to do in this video is talk about first the available CNIs that are out there today, and then talk a little bit about some sample data. So I've been sampling the community, gathering in some information on potential what CNIs are used, and then looking at that data and making some analysis based on that data. Now, this data or the sample information obviously is updated as you do more and more samples. You're going to get more data, but I think it provides a pretty good indication of what's being used. So I created this document to really cover the different types of CNIs that are used when integrating Big IP with Kubernetes and, of course, OpenShift. And I think that maybe the directions are going a little bit different directions, but let's talk about that. So this document really provides some sampling of available CNIs that are out there, and this document also provides how-tos on how to set up the CNIs, because remember, Big IP is outside the cluster, and that's one of the reasons why you're having to set up a CNI so that you can connect your Big IP external load balancer to the internal pod. And if you don't want to use a CNI, then there are other methods to do that, and we're going to talk about that in this diagram. So for those folks that are not familiar with a CNI, and I do apologize, I didn't put any diagrams in here, but there's so much information on CNIs, specifically around diagrams on the internet. But CNI ultimately is a container network interface, and it's really a framework for dynamically configuring network resources within Kubernetes. So the CNI really determines the potential pod subnet and how the pod is routed within the Kubernetes cluster or OpenShift cluster, or is routed between the nodes, or is routed ingress as well as potentially egress. So it's really kind of important. It gets back to the whole framework of the whole construct of networking to the pod, from the pod, and the nodes as well. So this is interesting because you can also determine a CNI as potentially how it enables the use of an overlay or an underlay network. In some fashion, yes, CNIs heavily utilize overlays, and one of the most common overlay networks is allowing encapsulation of network traffic using a virtual interface such as VXLAN or virtual extensible LAN. And that in itself is interesting, and let's take a look at the data. Let's see what the data shows us about the difference between an overlay and an underlay. And so the underlay network works at the physical layer, right, which is really your routers and switches. Okay, so we talked about the physical layer, which is the underlay. And then VXLAN is one of the protocols that are used in the CNI at the over the cloud or the overlay. Another one is potentially nginx. And so let's take a look at the protocols that use them. So I'm going to jump down to a little bit at the bottom here. But here we've got three very common CNIs that are quite heavily used. Flannel, Calico, and Cilium. Before we get into the diagram, let's take a look at these three. And if you go into these three links, I go into it extensively. So Flannel uses VXLAN pretty exclusively. Calico uses routing. So by using routing, it uses a routing protocol, and most of the time the routing protocol happens to be BGP. And so that means that the nodes are added to the BGP network, and then that BGP network is then shared with its peer. So in this case, the Big IP is the peer. And the next one is Cilium. Now, Cilium is pretty new, specifically on the Big IP front. Cilium was added in 1.12, which is the current version of Cilium. And so when we look at the graph, you're gonna see the Cilium numbers. So Cilium, by the way, also uses VXLAN, but Cilium can also use Geneve. Geneve is a similar type protocol. However, the stack is somewhat the same. It's just a little different. People might prefer Geneve. In fact, ovn-kubernetes uses Geneve instead of its default VXLAN. So you can see the industry maybe is transitioning. At least Red Hat is transitioned from VXLAN to Geneve with that if you want to call it maybe default CNI now, because OpenShift default CNI is ovn-kubernetes. Now, I don't show any ovn-kubernetes on my sampling graph, and we'll talk about that. So let's go into some of the sampling. So CNI used with F5 Big IP. So I've done some sampling, probably over maybe 1,000 plus deployments over 3 years, and these are some of the numbers that I'm getting. So you can see what's really interesting here. Of all the big IPs that are deployed with integration into OpenShift as well as Kubernetes, using something like CIS or the big IP controller in Kubernetes or OpenShift, I would say the predominantly used CNI would be Calico. And that makes sense. That makes sense because the integration of Calico and Big IP is pretty simplistic using BGP. I have a link down there that can kind of talk about it. And I think I might create a dedicated video on Calico. These numbers are actually quite surprising to me. 31% of all deployments out there are Calico. But that does explain, because Calico is the only supported CNI, or was traditionally the only supported CNI for a long time, probably for the last 3 years, that supported high availability, right? So your active standby big IP devices, the only way you could get that working specifically with Kubernetes was with Calico. And OpenShift had its solution, but it was a little bit harder to configure. I think with Calico, there's no over the cloud, or there's no overlay that you need to configure. It's really just configuring BGP. But to be honest, doing that is actually really simple in Kubernetes. And again, I got a link that can kind of, that you can use to follow that. So that's why I think Calico's used quite heavily. Look at that Cilium. The number of Cilium there is less than 1%, and this is just because Cilium was just added to CIS in 2.11. So 2.11 was the first integration of Cilium, and so within about maybe a month or two, we have potentially 1%. Or there is 1% that kind of samples. So I think Cilium will definitely climb, and I'll redo this video in 6 months. Or if you ask me to pull some sample data, or to look at to send out some samples, or ask some questions about who's using what or what's being used, I can look and get some of those sample data to kind of show you. Really, just it boils down to usage data, I think, or sample usage information more than anything, just to kind of share with you folks. So Cilium, you can kind of see, is at 1%, but I see Cilium will definitely probably be in line with Flannel. So there's quite a lot of Flannel there, maybe 5% of Flannel, which kind of makes sense. I think that's because it's default Kubernetes, but that tells me that it's single cluster Kubernetes, and maybe single big IP, right? There's potentially no active standby big IPs, because active standby big IPs can work with Flannel, but it's quite tricky to set up, and it doesn't allow you to create floatings. So I think that's kind of why it's a 5% versus Calico at 32% or 31%. That clearly shows the difference. Calico being more production, Flannel maybe being more dev test or test, right? Look at that number of node port. Now, you can argue node port, I wouldn't say is really a CNI. It's really just a method of how to expose a service, right? You got node port and cluster IP. Most of the time, the Calico and Cilium and OpenShift SDN are using cluster IP. Why is node port at 40%? I think that's just simplicity. So it gets back to not having to use a overlay, really just routing or just switching traffic to the kube proxy. But the caveats there is that your pool members are always the kube proxy on the node itself and not the pods. So big IP is not going to pods. But it tells me that users of big IP with the control of CIS are actually just doing something pretty simple and sending traffic to the nodes versus going directly to the pods. So maybe you could almost say that cluster IP in this case is 31% and node port is almost maybe 40%. So there's a 10% difference there. But that 10% difference comes with probably the significance of having to configure a CNI. Node port, there's no CNI configuration. Maybe also node port is just L4. And if you want some sample data on what ingresses are used or what resources are used, I can do that. Just put a comment in there and request that. I'll definitely do that. That's what I like to do on these videos. OpenShift SDN is interesting. OpenShift SDN is actually using VXLAN tunnels, very similar to Flannel. You could even call it that, maybe, or similar to that. So that's interesting. So maybe if you take the Flannel data and the OpenShift SDN data and you add those two together, you get half of the Calico, around about 15%, which is kind of interesting. OpenShift SDN by default is going to use VXLAN. OpenShift SDN, not that easy to configure if you're going through firewalls and if you're having to open up VXLAN tunnels or trying to troubleshoot VXLAN. It can actually get quite complex. There are some others here. There are some others that are detected, or there's some other samples that people are using that I haven't seen. In this instance here, maybe some of the others might also be, I'm using ovn-kubernetes. And so I will do another update maybe in a couple months when more users are using ovn-kubernetes in OpenShift. So ovn-kubernetes is now defaulting 4.12 of OCP, and I think the transition from OpenShift SDN to ovn-kubernetes will come. And so I think that as we start to get to like CIS 2.12, 13, maybe even 14, integration with OpenShift, maybe OpenShift 4.13, up and coming months, we're going to start to see more ovn-kubernetes. And so hence I need to do another update. But that's kind of interesting from that perspective. Now, huge benefit of OpenShift is using ovn-kubernetes with big IP and the integration of using just static routes, right? So we're using basically, if you could almost call it like an intelligence CNI or ICNI, if you want to call it that. That's one name for it. The Red Hat folks just call it maybe just advanced routing, and all big IP does is just route to the interface of the node, not to the proxy, but route to the interface, and then the interface basically just simply forward that on to the pod network. It knows what pod network is associated with that interface. So look at that data. There's multiple YouTube videos on my channel on that one. But I wanted to share this information after I've done the sampling because I get a lot of questions commonly asked, what CNI should I use, or what is the most common CNI? And this is a really good sample data of 3 years of kind of what's being used with big IP and CIS. And so you can see here, to recap, maybe about 40% of of node port. Maybe if I add up the OpenShift SDN and the Flannel, maybe about 15% of potentially Flannel in cluster IP, and then maybe 30+% of using Calico, which is the BG piece. But that's interesting because that's still, if you add up everything with cluster IP, that's probably still higher than the 40% there. So that does tell me that it's probably almost around maybe 45 plus maybe 50% of cluster IP, which I think is the benefit of using big IP when you're going big IP to pod, whether that's an application pod or it's an nginx pod, etc. So if you like this information, please give this video a thumbs up. Welcome to share it. Also, if you want to see more sampling data of resources, I can do that. Just I gotta get the sample data and build that. Send me a note, send me a comment. And if you're not subscribed, please subscribe. I'm trying to grow this channel. Obviously, the more subscribers, the better it is for the YouTube channel, for the YouTube algorithm, etc., etc. You kind of know that from YouTube. But that's where we are with what CNIs are used with big IP. Take a look at these links to configure. I just did a video on Cilium. There's lots of videos on Flannel. I need to do a video on Calico. I will record that in the up and coming months.